Here we go. Okay, so today we're starting chapter 6 and we are going to cover integer exponents today. And what I mean by integer exponents, I'm talking about exponents that are going to be either a positive number or a negative number. We're not going to get into the fraction exponents yet, just integers. So here it's just asking you to evaluate, and we've been doing a lot of this where we just replace whatever they tell you is the value of the variable and then solve it. Okay, again, when you have a base, that's going to be the big number, and then the exponent would be the little number, and then the answer would be what 4 times 4 times 4 is, and that's 64. But we're going to cover this. Okay, so we're going to be evaluating expressions that are going to have either a 0 exponent or an integer exponent. And then we'll also simplify the exponents also. Okay, so here's an example of, we've seen positive exponents, and we know that when it's 3 to the second power, this power tells you how many times to multiply the number. So 3 squared, and that's a special name that they give to the second power, is squared. But when you see a little 2 there, that means to take the base and multiply it 2 times by itself, and 3 times 3 is 9. Now, they're trying to establish a pattern here so we can see what's going to happen when we have an exponent of 0 and when we have a negative exponent, because we've seen the positives. Now, notice in our little chart here, looks like there's a pattern. Looks like to get to the next exponent that's going down, they're dividing by 5. So what do you think anything to the 0 power is going to be?
0.
Nope. What's 5 divided by 5? 1. Anything to the 0 power is 1. All right, so let's see who wasn't paying attention just now. And what is 1 million to the 0 power? 1. Good. Okay. Any number to the 0 power is always going to be 1. Doesn't matter what the number is. If you see a little 0 as an exponent, the answer is going to be a 1. So 5 divided by 5 gave me my answer, which is 1. But anybody know what 1 divided by 5 is going to be? Okay, it's going to be 1/5, or just know that's what we're going to be doing with the negative exponents. And again, if I were to divide 1/5 by 5, it's really like multiply by the reciprocal. So this would be 1/25. And this is what we're going to be seeing if you haven't seen negative exponents yet. Yes? No. A negative exponent doesn't make the number negative. That was an excellent question. Everybody sees a negative exponent and they think it makes the number negative. It makes it a fraction. So remember, a negative exponent makes the number into a fraction, not a negative number. So this is a preview of what we're going to see. So here they've explained it. Anything to the 0 power is 1. Anything to a negative power, you take the whole thing, put it underneath the 1, and then make the exponent positive. Here they took the whole thing, put it underneath the 1, and made the exponent positive. So again, here on this slide, they're showing you the names for each part of your exponent. The exponent is the little top number, the little blue one here. And then the base of this power is going to be x. So for example, if I have 2 to the 5th power, what is the 2? The base or the exponent? The base. What is the 5? The exponent. Okay, so the little number up top is the exponent. The big, larger number is your base, sitting down on the bottom. So here is what we just explained in words. Anything to the 0 power is always going to equal 1. When you have a negative exponent, so if I have 2 to the negative 3 power, doesn't make the number negative, it's going to take it and put it underneath a 1 and make it positive. Now, sometimes you might hear it as think reciprocal. So if you see a negative exponent, make it into its reciprocal. We're going to practice this. Now, if it asks you to evaluate this, anybody know what 2 to the 3rd power is?
Yes, 8.
Good. Common mistake that a lot of people make, they tell me it's 6 because they multiply. But 2 times 2 is 4, times 2 again is 8. Excellent. All right, so notice the phrase here, non-zero number. So here, this is because 0 to the 0 power or 0 raised to a negative power are undefined. So the base cannot be a 0. The exponent or the power could be a 0, but the base can't be 0 because it's undefined. So if we were reading this, this would be read as 2 to the negative 4th power. Okay, here is like an application, and it says 1 cup is equal to 2 to the negative 1/4 power gallons. So again, when you have a negative exponent, it does not make the number negative, it puts it underneath the 1. And then we would figure out what 2 times 2 times 2 times 2 is, and it's 16. Now, when you're doing these exponents, you're going to be evaluating some of them. For example, on the 2's, you can either decide I'm going to multiply this and get a 4, and then do it again now times the 2 and make it equal 8, and then do it again by 2 and equal 16. Sometimes what I like to do is I'd like to just take 2 at a time. You can choose whatever method you like. Sometimes I'll take 2 at a time. 2 times 2 is 4. Write that answer below it. And then do the other 2 times 2. And then it's easier for me to do 4 times 4 and get 16. When the numbers are bigger, it might be easier to do it this way. Okay, instead of doing it in order. Yes?
So when you have like a negative exponent, it's like doing it with a positive exponent, except it's like 1 over.
Correct. Good.
If you have a negative base, does it become positive?
It depends on the power, okay, and how it's presented to you. That was a good question. Okay, she says, what about a negative base? So if you have negative 2 and there's no parentheses around it, and let's say it's to the 3rd power, what this means is it's negative 2 times negative 2 times negative 2. Or actually, sorry, no, that's wrong. Let me correct that. What's happening here, if there's no parentheses, the sign drops down, and then it becomes 2 times 2 times 2. The answer is going to be the same either way. It's negative 8. Okay? However, if you have something like this, negative 2 in a parenthesis, raised to the 4th power, when it's held in that negative sign, this means it's going to be negative 2 times negative 2 times negative 2 times negative 2. Now, if I take 2 at a time, what's negative 2 times negative 2? Positive 4. And then same thing here, positive 4. What's positive 4 times positive 4?
16.
Okay, so this time when the base was negative, the answer turns positive. So keep in mind that you're going to have to think about it logically. A lot of times when your negative number is in a parenthesis like this, and the exponent is an even number, your answer will be positive. But if it's odd, it'll be negative. Yes?
What if both the base and exponent are negative?
Okay, so let's look at one of those. So let's say we have a base that's a negative 2, and let's say it's a negative 3 exponent. Okay, first of all, the negative 3 exponent is going to make this negative 2 go to the bottom. The base keeps its negative sign, but the negative sign on the exponent turns positive when you put it in the denominator. And now I would figure out negative 2 to the third power, which would give me a negative 8 over 1. So you're going to just have to take your time. I would move the negative exponent first and then deal with figuring out the power. Let's look at another example. So here is positive 5 to the negative 3 power. Again, the negative exponent doesn't make the number negative, it makes it a fraction. And then you would figure out 5 times 5 times 5. With the 5s, I'm going to do the 2 5s first. And then I'm going to, whenever I see the number 25, I think about quarters. How much money is 5 quarters?
$1.25.
So 125. So whenever I'm trying to multiply or divide by 25s, I think of quarters because everybody can count those quarters and figure out how much money they got in their hand. All right. Here are 4 more examples. Notice again, the exponent on this 4 is negative. So again, it's making it into the fraction. And then you would evaluate 4 times 4 times 4, and it's 1 over 64. Again, any number to the 0 power will always equal 1. I'm going to give you this question on the quiz. And some of you may not be paying attention right now, and they're going to get it wrong. Now, here again is the question with the negative base and the negative exponent. Notice both C and D look very similar. The difference is C has parentheses, and it's holding that negative sign with the number. But on D, the negative sign in front of this 5 is dropping in front of the answer, and then you evaluate. So C gives you a positive 1 over 625, but D gives you a negative. So be careful with the negatives. Yes?
And you don't put like the negative sign on the outside?
On the outside of the answer?
Yeah.
They did. So here, see how it's on the outside right here? This one doesn't have one. Because you're doing, when it's in the parentheses, you leave it inside the parenthesis. But on this one, what you're actually doing is 5 to the negative 4, you're going to move it to the bottom. And this isn't held in tight with it, so you're just going to put it out front and then make this 5, 5, 5, 5 and figure out what that is. So if it's not held in, just drop it right in front of your answer. Good so far? All right, let's look at another example. Now, on this one, the base is negative because the negative sign is in the parentheses. However, on this one, this base is a positive 3. You're not looking at it with the negative sign. It's not being held tight in a parentheses. So that negative sign would drop. So the difference between the two, and this is a common mistake you're going to make, is the first one, you're going to do 1 over negative 3 to the positive 4. And this is going to become 1 over negative 3, negative 3, negative 3, negative 3. Now, when I do this, again, I'm going to do it as get a positive 9 and a positive 9, and then 9 and 9 is 81. However, the other example, this negative sign is going to drop in front of your answer. And then you'll move the 3 to the bottom. And then this answer, once you figure out 3, 3, 3, 3, is going to become 1, negative 1 over 81. Oh, I wrote it backwards. 81, not 18. Everybody getting the hang of this? All right. Here are 4 more examples. Again, -4 exponent makes it a fraction, and then you would figure out 10 times 10 times 10 times 10. This one, the negative sign is held in, and it's a negative exponent, so negative, negative. The -4 makes it go to the bottom, and then you would multiply the -2 4 times. Again, this one's held in, so -2 5 times. But this one, the negative sign isn't held in, it's dropping right in front of your answer. And then the 2 is the only thing that's being raised to the 5th power.
The positive is held in until it's still positive.
Say that again?
If a positive base is held in, it's still positive.
Yes. Now we're going to look at variables. Yes. Okay. Next, we're going to evaluate. Now, whenever you evaluate a variable, what you're going to do here is when you put it in here, the 4, when you replace a variable, you're going to put it in parentheses. In this case, the x was positive, so it really didn't matter. So negative exponent makes it a fraction. So 4 squared, 16. Okay, again, we're going to replace -2, a to the 0, b to the -4. I'm going to replace, and I'm going to put 5 to the 0, -3. So when I put them in, I'm putting my substitutions in parentheses. Okay, I need to follow PEMDAS here. I can't multiply first. I got to evaluate the exponents first. So I'm going to do each one separately. So what's 5 to the 0 power? 1. I'm going to drop down my -2. And now I'm going to do the -3 in a parenthesis to the -4 power. The -4 tells me, make it a fraction. Keep it in parentheses. And now I'm going to multiply -3, -3, -3, 4 times. We just saw this, and 3 to the 4th power is 81. So now I have this part being 1 over 81, and it's positive. Now I'm going to multiply what's left. So I can put 1s underneath these. So -2 times +1 times +1 is -2. And then straight across the bottom gives me 81. And that's your answer. So you will be simplifying these exponents. We are not using calculators. You will have to do all this multiplication by hand. Okay, next one. Again, we're replacing the letter P with the value of 4. So I'm going to write 4 to the -3 power. I'm going to now turn this into a fraction because it's a negative exponent, and then it becomes 1 over 4 times 4 times 4, which gives me 1 over 64. Let's look at the next one. Again, we are going to substitute. We are going to replace the letter A with the number -2. We are going to replace the letter B with a 6. I want to see you replacing this when you're doing your homework. So we're going to write 8. Going to take out the letter A. I'm putting the value in parentheses. It's going to make a difference. Then I'm going to take out the letter B. and I'm going to put a 6. And now I'm going to evaluate each power separately. So negative 2 to the negative 2 power becomes 1 over negative 2 and then the exponent becomes positive. I'm going to drop down the 8. I'm going to drop and I'm going to evaluate 6 to the 0 power. 6 to the 0 power is 1. Now I have to figure out the middle part. Negative 2 times negative 2 is 1 over 4. I'm going to turn my 8 into a fraction and my 1 into a fraction. So now I can multiply straight across. All the way across the top there, let me do it as a highlight, is going to be 8 times 1 times 1, which is going to give me 8. Then straight across the bottom, 1 times 4 times 1 gives me 4. I'm going to simplify this. 8 divided by 4 is going to give me 2. Here again, it says, what if you have an expression with a negative exponent already in the denominator? To make it positive, we're going to flip it to the reciprocal. So this is explaining how it comes about, but bottom line, what you're doing, if you have a number that's already in the bottom of a fraction with a negative exponent, to make it positive, think reciprocal and just pull it out and put it in the top and make it positive. So to rearrange this and make the exponent positive, think reciprocal. You could have thought of the original ones that we did, 2 to the negative 3 power, make it a fraction, and then to make the exponent positive, flip it to the reciprocal. So whenever you see a negative exponent, think reciprocal. Flip it upside down, and then the exponent turns positive, and then you will evaluate. Okay, so let's look at an example here. So here we go with part A, and it has 7w to the negative 4. I need to make my exponent become positive. We've already been seeing at the beginning that when you have a negative power, you just move it to the bottom of a fraction. Notice this negative 4 is only on the w. It's not on the 7. So the 7's going to stay in the top. The only thing moving to the bottom is the w. Okay, then on part B, notice that the k has a negative exponent. To make it positive, we're moving it to the top. The 5 is already positive. It's a negative number, but it's got no exponent. So it's staying where it is, but the thing that's negative has to go to the opposite spot of where it is. So to make it positive, you move it to the top. Wants us to rearrange and make this positive. Okay, so first thing I'm going to do is move anything that's negative. If it's in the top negative, move it to the bottom. So for example, I have a to the 0, b to the negative 2, c to the negative 3, and d to the 6. So the things I need to think about moving are going to be the b and the c. Those are the two things with negative exponents. To make them positive, I move where they are. If it's negative in the top, put it in the bottom and make it positive. So the b moves to the bottom. The c moves to the top. The a was already there. and so is the D. They're positive, they're staying put. Now, what's one other thing I can simplify? The a to the 0, which gives me what? 1. So my final answer here is just going to be the C that I moved, the B that I moved, and then the D that was there. Because this equals 1, and I don't need to show it. So you're going to be doing a lot of just rearranging. If it's negative in the top, put it in the bottom and make it positive. If it's negative in the bottom, move it to the top, make it positive. Here's another example, 2 more examples. So we have 2r to the 0, m to the negative 3. The thing I need to move here is this negative guy. Where does he go? Underneath. So 2r to the 0's in the top, m to the 3, third power is going to the bottom, and he's positive now.
And the R 0 disappears because we don't need to show it.
Good, because I don't need to show 2 times 1. Now, if the 2 wasn't there, I would just simplify it to a 1 and leave the 1 behind. So this simplified answer is now 2 over m to the 3rd. Let's look at part B. I have r to the negative 3 over 7. Okay? What's going to move? The negative moves. To make him positive, he's got to go to the bottom of the fraction. Now, because nothing was left behind, I need to leave a 1 behind. On part C, g to the 4th over h to the negative 6. Yes?
An exponent, a base with an exponent that says 1 is treated the same as an exponent that's 0.
Yes. Because 1 to any power is 1. And any number to a 0 power is 1.
And we can treat it the same.
Yes. All right. This one, what's going to move here is going to be the negative 6. To make it positive, it's just going to go sit up top with that G. And there's your answer. Guys getting the hang of it? Almost done. All right, we've got 4 examples to simplify. Again, negative exponent doesn't make it negative, it makes it a fraction. So here I would do 2, 2, 2, and I would get 6 2's here. Once you figure out what 2 times 2 times 2 times 2 times 2 times 2 is, it's actually 64. So 1 over 64. For number 3, you're going to take the whole thing, held inside with the parentheses, move it to the bottom, make the exponent positive, and now we're going to multiply. Negative 7, negative 7, negative 7. Negative and a negative gives you positive 49, but then when you do it times another negative, the answer now is finally negative. So be careful with your negative signs. And again, anything to the 0 power is 1. This negative 11, the negative sign drops, and then the 11 is left to be squared. So this becomes negative 121. Yes?
Could you also do like 1 over negative 314?
Yes. So number 5 in the PowerPoint is right down here. So what you're going to do is the negative sign isn't held in. So it's going to drop straight down, and then this exponent is only on the 11. So then you would write 11 2 times. The negative sign is out front because nothing's holding it in. And then you would multiply 11 times 11 and get 121. And it's negative.
Why isn't there, why didn't you do it like 1? Why
Because the exponent wasn't negative, it was positive.
Oh.
The only time you make it a fraction is if this little power up here was a negative number.
Okay.
Yes?
How about the Whiteboard problem?
The word problem in the homework?
17.
Okay, I'll look at it. Okay, and then here's another one where you're substituting the variables. Here on A and B here, these are going to go to the bottom of the fraction, and then you would put in those values. Cube it and then multiply it. Okay, your homework tonight is practice A. It's on Canvas, and it needs to be turned in. So everybody go ahead and open it up. I know we only have about 5 minutes left, but go ahead and open it up. Let me make sure that you guys can access it and let me know.